So in the last video, when your computer needed to turn a name like google.com into an actual number and address, something like 142.250 and so on, I waved my hand at it and just called it the internet's phone book. Name goes in, number comes out. That is the starting picture. But honestly, it is not really one phone book at all. And that is the part that actually makes the whole thing work. So here is the question I want you to hold for the whole video. That number, the one your computer actually has to connect to, who knows it? Like, if you had to point at one machine on the entire internet and say, that one has the answer. Who is it? Keep that in your head. Because your first instinct is probably there is some giant master list somewhere, but think about it. There are hundreds of millions of website names, and every new site, every little change would have to go update that one file. It would be out of date the moment it was printed. So a single giant phone book just does not work at internet scale. And here is the part that got me the first time. When your computer goes looking, it quietly hands the job to a helper. And the first place that helper checks does not know the answer. And the next place does not know either. And that is not a bug. That is exactly how it's supposed to work. So let us walk it. How a name becomes a number when nobody is holding the whole map. This is DNS, the domain name system, properly this time. And by the end, propagation and why one website can hand back different numbers to different people, all of it is going to make a lot more sense. Okay, so if it is not one big list, what is it? And the answer is kind of hiding in the name itself. Let us take a real one, www.google.com. We read that as one word basically, but it is not one word. It is a little path made of pieces, and each piece is called a label. www is a label, Google is a label, com is a label. And here is the thing, those pieces are actually a tree. At the very top, there is the root. This is the whole internet starting point. Under the root sits com, under com sits Google, and under Google sits www. So the name is really a branch, root, then com, then Google, then www. And now the part that flipped it for me. We type it left to right, www.google.com. Most specific part first. But DNS reads it the other way. It starts general and works down. First, who handles com, and then who handles Google under com, and so on, right to left. There is even a tiny hint of this hiding in plain sight. Technically, every name ends in one more dot for the root. You just never type it. And the reason it is shaped like a tree at high level is so each branch can be somebody's separate responsibility. Com is one branch, Google sits on its own branch under it. We will see in a minute exactly why that matters so much. But the anchor to hold for now is just this. We write it like a sentence, but it is really a tree. Read from the right. So if the answer is spread across this whole tree, does your little browser go climb all of it by itself? No. And honestly, thank God, because that would be a lot of work on every single click. Instead, your browser hands the whole question to one helper. This helper has a name, the recursive resolver. And recursive here just means you give it one question and it promises to go get you the complete answer. However, many steps that takes. Think of it like you do not personally call five different departments to track something down. You ask one person, just find out for me, and they go make all the calls. And this helper is usually run by your internet provider, sitting quietly in the background. Or it might be a public one. You have probably seen 8.8.8.8, that is Google's, or 1.1.1.1, that is Cloudflare's. Either way, same deal. So your computer does not need the map of the whole internet. It just needs one helper who knows how to walk it. And now let us actually watch that helper walk. So the helper starts at the top, at the root. And here we get to answer that question from the very beginning. Who knows Google's number? Your gut says the root, right? It is the top of the whole internet. Surely it knows everything. It does not. The root does not have a Google's number. What the root has is a list of who is in charge one level down. So it basically says, I do not know Google, but anything ending in com is handled over there. Go ask the com servers. And it points. So the helper walks over to the com servers. These are called the TLD servers, top level domain. That is just the com or the org or the dot in the part at the end. And here is the pattern repeating. Com also does not know Google's number. And what com knows is Google's own servers handle everything under google.com. Here is where they are. And it points one step closer. Now the helper reaches Google's own servers, the authoritative servers. Authoritative just means for this name, these are the ones actually allowed to say what is true. They own the records. And finally, this one has the real answer. Yes, google.com is this number. And that answer walks all the way back down to your browser. So notice what actually happened because this is the whole idea. The root did not know the answer. Com did not know the answer. Each one only knew who to ask next. Nobody in that chain holds the whole map. Each level just owns its own slice and points you one door closer. That is delegation. Nobody knows everything. Everyone knows the next door. And one quick thing so you are not misled. There are only 13 of these routes at the very top by name, but each name is actually copied across thousands of machines around the world, and you just get routed to a nearby one. So it is 13 names, not 13 boxes. Okay, small thing that is actually a big thing. That answer that came back, it is not just the number. DNS does not really do what is this website. It answers a much more precise question. For this name, give me this type of thing. And there are different types. The address one, the number your computer actually connects to, that is called an A record. And that is the one we have been chasing this whole time. But here is the thing, same name, you can ask a completely different question as well. Ask for the MX record and you get back something totally unrelated. Where email for this domain should go. So Google's website and Google's email live under the very same name, but they are just different records. Same name, different question, different answer. And there is one more thing that really matters because you hit it constantly without ever knowing. The C name. A C name is not an address at all. It is an alias, basically a signpost. It says this name is actually just another name. Go ask that one instead. So let us say a small shop points its www name at something like shop.somecdn.net. Your helper asks for the shop, gets back, no, it is really this another name, and just restarts the lookup there. And this is exactly how a small site quietly hands its traffic to a big CDN, a content delivery network, which just means copies of the site kept on servers physically closer to you. Same trick as the last video, shorten the trip. One honest catch, because it trips people. A CNAME redirects the lookup, not your browser. Your browser is not getting bounced around. It is just DNS behind the scenes following a signpost to the real name before it ever hands you a number. DNS is not a yes or no lookup. It is a typed question. Okay, so we just walked the route, then com, then Google, several hops across the internet. That sounds slow. So why does DNS feel completely instant almost every time you use it? Because it remembers. That is that caching idea from the last video. And this is its home turf. Every answer that comes back carries a little timer with it called the TTL, time to live. And it just says how many seconds the helper is allowed to reuse this answer before it has to go ask again. Let us say the TTL is 300, that is 5 minutes. For the next 5 minutes, anyone using that same helper who asks for google.com gets the answer instantly, straight from memory. No ladder at all. And there is a second half to this that really matters. The helper not only remembers the final number, it also remembers who runs com and who runs google.com. So even after the number itself expires, it does not start over from the root. It already knows the last step. and gems almost tried to Google's own servers. That is why, in practice, the full climb we just did is the exception, not the rule. Most lookups are short. It even remembers the misses. Let's say you mistype it, some name that just doesn't exist, the no such name answer comes back, and the helper remembers even that for a while. So it is not re asking the whole chain for a dead name. And now, this finally explains something you have definitely heard. When someone changes their DNS, people say give it 24 to 48 hours to propagate, like the change is slowly spreading across the world, but honestly, nothing is spreading anywhere. The moment you change your record, it is already live at your own authoritative server. What is actually happening is that old answers are still sitting in caches all over the world, each one with its own little countdown, and they only go away when their timer runs out. There is no single moment where the internet updates. So, DNS is fast because it remembers, and DNS changes feel weird for the exact same reason. Okay, nearly there. One more thing about that answer, because honestly, it is not quite as fixed as I have been drawing it. Here is the thing, a giant like Google does not even have one address, it has many, spread all over the world. And remember, the answer is just a record that Google controls. So it can hand you back a different number depending on where you are asking from. Someone in India gets a nearby server, someone in London gets a different one. Same name, a closer answer. And that is a big part of why the huge site feels fast, no matter where you are. Now, it is a bit coarse because all of that caching, it is really steering whole batches of people, not every single click. But the one thing to hold, DNS only points you at an address, it does not carry your data. The actual routing happens after that part, it's not DNS job. And one last pair quickly, just because people always mix them up. Signing versus hiding. DNSSEC signs the answer, so your helper can check that nobody swapped in a fake number. But it does not hide anything. Signed is not the same as secret, and DOH or DOT DNS over HTTPS or over TLS do the opposite. They hide your question from your local network, your cafe Wi Fi, by scrambling it on the way to your helper. But your helper still sees it, of course. It is the one answering. So one proves the answer, the other hides the question. Neither one is the other. Okay, let us pull all the way back out. You ask for a name. Your browser hands it to one helper. The helper goes to the root, which says ask com, and com says ask Google, and Google finally gives the number. And then the helper remembers the whole path, so next time it barely has to walk at all. And if you hold on to just three words, you have got the whole thing. Delegate. Nobody keeps the full map. Each level owns its slice and points one step closer. Answer. Only the server that actually owns the name gives the real thing, and it is a typed record, not just a number. And remember, caching is why it is fast, and cache expiring is what propagation really is. Delegate, answer, remember. So, that phone book we started with, let it go. A phone book is one giant list that somebody has to sit there and keep updating forever. DNS is almost the opposite of that. It is a chain of responsibility where no single server is in charge of everything. And that is exactly why it can hold the entire internet and still answer you in a few milliseconds. No one holds the whole map, everyone just knows the next door. And honestly, hold on to that idea because it is bigger than DNS. Nobody in charge of everything, each part just owning its own slice and pointing to next. That is how almost every huge system on the internet survives its own size. That is just the first place you really get to see it. That is the whole thing. And look, now we finally have the number, which means we can go do what we came for. Actually open up the connection to that machine and set up the padlock. That secure handshake is its own thing, and honestly a good one. That is the next video. So if you want to keep going deeper into how all of this works, stick around.